Så, då är klockan 12:30 och jag säger välkomna till det här seminariet som idag har rubriken Fakta och myter i klimatdebatten. Det här seminariet är en del i vad vi kallar för ekoskolor där vi bjuder in gäster för att hålla föreläsningar och seminarier i intressanta ämnen. Och vi har inlett också ett samarbete tillsammans med SVT där vi hjälps åt att komma på intressanta ämnen och också att arrangera de här träffarna. Och idag är ett sådant tillfälle där vi gör det här gemensamt. Och vi sänder via Facebook Live för de som är med i gruppen Sociala Ekot, så man kan skriva in frågor som vi kan ta sen efter Kevins föreläsning. Och ämnet idag är alltså fakta och myter i klimatdebatten. Miljö och klimat kan bli stora frågor i valrörelsen, men det är frågor som vi i alla fall rapporterar om och berättar om regelbundet. Hur klimatförändringar påverkar våra liv och vår miljö. Många säger att hoten är många och stora, men det finns också de som säger att de är överdrivna. Så hur ska vi förhålla oss till vad som sägs? Vad är fakta och vad kan vi lita på? Och den som ska prata om det här idag är Kevin Anderson som är våran gäst. Och jag måste läsa innantill för hans titel är så lång. Han är professor i energi och klimatförändringar vid universitetet i Manchester. Och han är också Uppsala universitets Sennström-professor i klimatledarskap vid Centrum för miljö- och utvecklingsstudier. Och föreläsningen hålls på engelska och vår medarbetare på engelska redaktionen, Lucas Christodoulou, kommer att kunna översätta om det är så att man vill ställa frågorna på svenska. Så finns han här också och du ska få inleda lite kort.
Okej, det finns inte så mycket för mig att säga egentligen. I just want to thank Professor Anderson for coming to talk to us, really. It's him that you want to talk to. Like we said, I'm going to be available to translate either from English into Swedish any issues, or from, if you want to ask a question in Swedish, I can translate that into English. And those of you watching at home on the Facebook or other broadcasts, if you write your questions in the comments, we'll check those out and bring them into the discussion, which will happen about halfway through. Thanks very much. Take it away.
My pleasure. Thank you. Can you all hear me through this? Wonderful. And I'll start off with an apology that as a typical British person of my generation, I haven't yet learnt many other languages, and certainly not Swedish. So I'm sorry, this will be in English. And I also have a very bad habit of speeding up, talking faster and faster. So if I'm talking too fast, just tell me to slow down. Though I always say to the students, if they could listen quicker, would be helpful. So I've called this here Revealing the Naked Emperor, and hopefully you're all quite familiar with the story of the Naked Emperor, and that no one dares to call out that in fact that the emperor is naked, except for a small innocent child in the end. And I think when it comes to climate change, we are still like this, particularly in terms of reducing our emissions. We've spent a lot of time talking about it, but actually the emperor, the mitigation emperor, the carbon reduction emperor remains as naked as it was 27 years ago, and I'll come back to that. And then I'm going to focus a bit on Paris, 2 degrees C, and carbon budgets. And I'm also happy if as I'm talking, things aren't clear, if you just want to, just please call out or put your hand up. I mean, it's useful to clarify things. You always guarantee if something I'm saying is not clear, then there will be other people who will not understand it either. So I'm going to start off. I'm not sure what all your backgrounds are, other than obviously are journalists of one form or another. And I'm going to start off with the Paris Agreement. And just taking the simple part of this, it's a 32-page document. I'm going to focus here, for the part I'm looking at today, on these commitments to hold the increase in global average temperature to well below 2 degrees centigrade, above pre-industrial levels, and to pursue efforts to limit temperature increase to 1.5. But also to do this in accordance with the best science, and also on the basis of equity. And I've circled equity there because this is really just used as lip service by every part of the world, including the new Swedish climate change law, the Climate Change Act in the UK in 2008, that no nation, not even the wealthy nations, have made any real allowance for the equity component of the Paris Agreement. And the equity component was not new to the Paris Agreement. It was there in the Camp David Accord. It was there in the Copenhagen agreement. It was back in the Kyoto Protocol. So equity has been right the way through the discussions, but no nation has actually taken this seriously. And it actually makes, well, if you take equity seriously, it significantly makes the challenges more difficult for the wealthy parts of the world. It's also worth bearing in mind that in Stockholm or Uppsala, or where I come from in Manchester, that 2 degrees centigrade of warming doesn't, I mean, it's not very helpful. Say on a cold day in Uppsala, 2 degrees warming, you think, well, that'd be quite nice. But this is a global average, and the global averages have huge repercussions geographically around the planet, and also they have big implications during extreme weather events. So the average is really quite unhelpful, and we should really not have used an average, not for communicating more widely. So, but we are where we are now. We've been using this for a long time. But remember that 2 degrees centigrade can be 6 degrees in the poles. You're going to, at 2 degrees C of warming, most of Greenland will melt. Not in our lifetimes. It will take quite a few hundred years. But within the probably next 10 to 30 years, we will have locked in the melting of Greenland. That's 7 meters of sea level rise. So let's not think that 2 degrees C of warming is small. Many people will suffer. Many people will die at 2 degrees centigrade of warming. They'll be poor, they'll be low emitters, they'll typically be non-white, and they'll live a long way from here. So we know who they are. And that's why in the Paris Agreement there was a lot of pressure for 1.5 from some of the poorer, more climate vulnerable parts of the world, because for them the impacts of 2 degrees C are just unacceptable. So they pushed for 1.5. But again, because I don't know what all your backgrounds are, I think it's just worth remembering. In fact, a lot of the science community forget this, and it's really worth thinking about this, that our concern with climate change does not relate to temperature, but actually relates to impacts. What are the impacts that we're going to face from climate change? And science can actually describe what those impacts are, so we can understand what impacts there'll be at different parts around the world with some uncertainty and for different temperatures. So it could be sea level rise, biodiversity loss, droughts, floods, extreme weather events, ice loss, regional temperature change. We can say something about that quite robustly from the science, but with the usual ranges of uncertainty. And these can then be related into the sort of things that we might think about from a human perspective: agricultural yields, changes in food patterns, vulnerability to extreme weather, human migration, and how these things might play out against other tensions that are felt in different parts of the world. So it's the impacts here that are important. So temperature rise across the century, which is what we're talking about when we talk about 2 degrees centigrade or so, actually is just a shorthand for climate-related impacts. And we have to remind ourselves of this. We are actually talking about impacts, not really about temperature, but it's a good proxy that we use. And the second part I'm just going to go through, because I'm not going to talk too much about the science today, more about what we need to do about climate change, but just to sort of clarify a few points on the science. The greenhouse effect is uncontested. It's just a basic rule of science that we've understood for the last 200 or 300 years, pretty much. And that without it, the world would be, on average, minus 18 degrees centigrade. So it's uncontested. So whatever the skeptics or the denialists might say, without the greenhouse effect, we wouldn't be here, and nor would they. So maybe some good things from that. Climate change is also uncontested. The climate has and will always change on the basis of all sorts of things that just happen with how the Earth moves relative to the sun, and a whole sort of other things with sunspots and other things like this. So the climate has always changed. That humans contribute to recent observed climate change. We have observed climate change categorically. We know it's happened certainly in the last 100 or so years, and definitely since the 1950s. We can see a very clear change in the temperatures and therefore the climate. And this is uncontested, and the humans have had some part of that. It's also uncontested. Now, exactly what the contribution has been, there's still some differences in that. So again, a high degree of certainty, and there's the nuances, it's the variations where the differences reside. Now, this is the most important part, really, from where we are today, is that what will the exact human contribution to future climate change be? And obviously, that is still contested, partly because we don't know what the emissions of carbon dioxide and other greenhouse gases will be, but also because we don't know exactly how the climate will respond. So there are some climate science issues there about what we call climate sensitivity, and then there are other issues about, well, what are we going to do with our emissions? But broadly, again, we are very confident that humans will have a significant impact in the future, and that can be made less significant or more significant depending on how we act. So there's some certainty. So that's the only bit of science really here. Now, I think it's quite important that we have to remind ourselves of where we are now. This is 2017. And we had the first set of IPCC reports came out in 1990. So 27 years ago. Normally, if I'm talking to students, I can say it's before they were born. In fact, it's before some of their parents met. some of you here will probably, you were definitely here 27 years ago, so it's slightly different with this audience. But I just think it's worth bearing in mind when we're talking often to students particularly, that we're talking about right throughout their lives, we've known what we need to do about climate change. In 2016, emissions will be 60% higher. Well, in 2016, they were 60% higher than they were in 1990. So despite having all of this information available, for over a quarter of a century, we have failed. And actually in 2017, despite a recent plateau, emissions again are going up. And that plateau was significantly driven by the banking crisis and the economic slowdown at a worldwide level. So emissions are still rising. And this year, they're probably going to have gone up by about 2%. The recent information came out during the Bonn Climate Change Conference. So 2017, emissions are still going up. So despite a lot of optimistic rhetoric, which we still regularly hear, we've actually delivered 27 years of abject failure on climate change. And I think it's worth reflecting on that. And when you're ever interviewing someone, if they've got, as I often say, if they've got grey hair, no hair, or dyed hair, and they claim to be a climate expert, this climate expert has been part of a community that has fundamentally failed for 27 years. And I think a bit of humility there is really sometimes worth us bearing in mind. And who are we failing? We're not just failing ourselves, we are failing our own children and people elsewhere. So there are some really quite strong sort of moral arguments about really who should be advising us now. Should it be people like us, or should it be other people who are impacted or likely to be impacted? But what have we done during this 27 years? Well, I would argue, and I've tried to make this slightly politer language than I would normally use, I've called it a litany of technocratic frauds. I used to have some slightly stronger language, but I've honed it down a little. So what have we done? We had offsetting, where effectively we paid poor people to diet for us. We won't make the reductions, someone else will make it, and we'll pay them. The clean development mechanism, which is basically just state-sanctioned offsetting. In other words, a country won't make the effort, someone else will. And this happens all the time. The UK government can claim that it's going to expand its airport and develop more shale gas, or develop shale gas, and that fits with its carbon commitments, because they're going to pay Ghana or Nigeria or some other part of the world to make reductions for them. I mean, the maths don't work out either. Then we had the emissions trading scheme, with in fact so many permits made available, so it had almost no effect on industry, so the price was virtually zero, but we could pretend we were doing something about it. And now, so these things have all failed, we've now got negative emission technologies. It sounds quite attractive that you can go and buy them from Eco or somewhere else. These things don't exist. They're speculative technologies for the future, perhaps. And if they fail, then we've got geoengineering. We're going to pump sulfates into the stratosphere to reflect sunlight back out into space. We haven't, for 27 years, tried mitigation. So despite recognizing that this is a problem for increasing use of fossil fuels and increasing carbon dioxide emissions most significantly, we haven't yet, in 27 years, tried absolute mitigation. And even in Sweden, which is probably one of the most progressive countries in the world, certainly if you come from the UK, you would see it as a progressive country. The lifestyles of the typical Swedes in 2017 are about the same carbon level as they were in 1990. Once you factor in aviation and shipping and imports and exports, and of course every country deliberately doesn't include those because it makes it look like they're doing better than they really are. So even in Sweden, the emissions are very similar to what they were in 1990. And some countries I visited recently, I think it was the Netherlands, about the same. Belgium was 25% higher. So you start to look at lots of parts in Europe even are still higher emissions than they were. Norway's a lot higher. Your morally bereft cousin, as I often refer to them. So my interpretation of climate change, and I had this well before, well, I've had the same sort of view for probably 10 years now. In fact, I think exactly the same wording from a paper I wrote with a colleague in 2008, is that in developing 2 degrees C emission scenarios, so looking at the future for 2 degrees centigrade, we've applied, and the we here I mean significantly the academic community, but also supported by the NGO community. We've applied questionable assumptions, and we've fine-tuned our analysis to fit with political and economic sensibilities. Universities, non-governmental organizations, businesses, policymakers across the board, we've been co-opted by near-term power. We want to be in Davos. We want to be in the meetings with this apparently the powerful people. And so what we've done, we've adjusted our analysis, we haven't fiddled the analysis, we've changed the assumptions. We tune things to make sure the results nicely fit with the current socioeconomic paradigm. We dare not question the paradigm. So we've had 13 billion years of physics since the Big Bang, and physics has worked fairly well for 13 billion years. We've had this new economic model for, what, 30, 40, 50 years at most. So we've had this ephemeral economic model. And we now will actually question physics rather than question the economic model. That's the position we're in now. Supposedly sophisticated people in the 2017 are questioning physics rather than the socio-economic paradigm. And beyond that, engineers, and that's where I come from, I have an engineering background. I used to design and build offshore oil platforms. But engineers always have their pet technologies. People who like nuclear will solve it, or wind will solve it, or solar will solve it. So there's always something, or energy efficiency will solve it. There's always something that's going to be the silver bullet for the future. So I think we have not been helpful here. We've not thought about energy systems or about the system in total. So my take-home issues to consider and this is me trying to interpret what's important for journalists, so I mean, I don't really know, so I've made my best guess here, is firstly, when it comes to climate change, it's carbon budgets that matter, and I'll come back to this in a minute. It's not long-term targets. What we do in 2030 or 2040 or 2050 is irrelevant from a temperature point of view. And scientists like myself and others have been using this as a proxy for too long, and we shouldn't have done. It's been really misleading. I've had a lot of arguments with my colleagues about this for at least 15 years, that long-term targets undermine real mitigation today. It's also, I would go as far as to say, the Paris commitments are far, far more challenging than you will virtually ever hear from scientists, especially if they've got a microphone near them. If you get them with a beer or a glass of wine or something, and then, or maybe 2 beers or 2 glasses of wine, then you'll start to find out how severe the challenge really is. But if you get them anywhere near a microphone or a journalist, then they're not going to tell you. So, and I hear this repeatedly across the board, particularly from senior scientists, that we're now relying on non-existent negative emission technologies to magic our way out of the problem. The climate change law in Sweden doesn't talk about these, but I'm fairly confident it is using this to underpin its analysis. The Committee on Climate Change in the UK, who advised the UK government, actually has this mentioned in a footnote on page 42 of its recent advice to government. So if the policymakers read the footnote of a 50-page document, then they might spot that these are there, but they wouldn't know otherwise. So I'll come back to these later. But actually, although it sounds like quite a depressing message, I think at the moment we can still just about hold to 2 degrees C warming if we're prepared to mitigate emissions. So let's go into the carbon budget framing first. And I say I don't know what you know about this, so maybe this is something you're quite familiar with. Just think of this graphically. So we've got some emissions going up here. This is carbon dioxide at the side and the years out at the bottom. So we've got emissions going up here. This is just stylistic at the moment. And what really matters is the area under the curves. This is our total amount of carbon dioxide. Remember, when we put carbon dioxide into the atmosphere, that carbon dioxide will be there it'll be there for centuries. Some of it will be there for 1,000 and more years. From any realistic sense, carbon dioxide is permanent in our atmosphere. Some of it gets pulled out quite quickly, but there's a build-up of the part that doesn't, and that gets built up year after year. And that's the problem with climate change. It's a cumulative problem. So every year you fail, it is much more difficult to solve the following year. So what happens down here doesn't really matter. What matters is the area under the curve. So if we choose to fail, so in Sweden they're looking to expand our London airport, another airport up north. You've now got a liquefied natural gas terminal being planned for Gothenburg. So Sweden is planning to maximize its CO2 emissions. By doing that, then we make sure we don't stay within the budget, which means that the future generations, because it's not us, it's future generations, will then have to suck more CO2 out of the system one way or another. In other words, their mitigation rates have to be much higher. And I'll come back later to say that simply won't be possible. So our choice to fail today is locking in the future. We cannot say, well, just do easy incremental things today, and then we'll solve the problem later. That doesn't work on climate change, because the science doesn't allow it. So let's try and frame the mitigation challenge. So we've got this 1.5 and 2 degrees C of warming. As I say, this relates to sort of sets of impacts. And if you plot them out at a global level, I'm not going to go into the detail here, it looks something like this. And actually, there's not a lot of variation in this because there's so little carbon budget left, because we've deliberately chosen to waste the carbon budget over the last 27 years, there's almost nothing left. So that's the carbon budget here. And if you start to look at these curves, as I say, you can't make the curves go this way, because that would mean the carbon budget is too big. If the carbon budget is too big, then we have a much higher temperature. So we're stuck by the carbon budget. Then for 2 degrees centigrade, by about 2036, the midway through the 2030s, we have to be reducing at about 11% every single year. So just think about that in your own lives. That is just an enormous change. And we have to get up there quite quickly. So we start ramping up quite quickly to this level. And for 1.5 degrees centigrade, that poorer Poor, very low emitting countries have requested, and we've agreed to try and help them with, we need about 20% per annum during the 2030s. Now, remember, this is at a global level, and the equity component requires us in the wealthy parts to lead on this. So it would be much more challenging than that for Sweden or for the European Union, for instance. But when you look at the IPCC, that's the Intergovernmental Panel on Climate Change, all the other numbers are taken from what's called Working Group 1, which is basically just the science. So the IPCC, are you all familiar with the IPCC? Okay, so the Intergovernmental Panel on Climate Change, which collect together all the science data, has different working groups. And Working Group 1 is basically just, if you like, the nearest thing we have to the physics. So it's just people with white coats doing physics. It's not quite that simple, but it's a bit like that. Working Group 3 is the mitigation group that look at how we solve the problems. And that's highly politicized, and it only has one particular way of looking at these things. In my view, it shouldn't be part of the IPCC. But this is the median values from Working Group 3, which is dominated by economists with some engineers, but dominated by economists. So they look at a much more attractive curve. It dramatically reduces the mitigation challenge. So as a policymaker or as a citizen, we might think that's much more attractive. It offers nice narratives about how we can make incremental nudge-type changes to solve problems of climate change. But it's built on a complete utopian alliance of technology and economics. And no one I know who works in these models thinks that they're viable. They're politically suitable for now, but they won't work. So the science is telling us this, and the economists are telling us that. And how are they doing that? Well, they're doing that because they've conjured up a new technology that doesn't exist. And it's these negative emission technologies. And there are virtually no exceptions to this in the major advice that's given to governments from Working Group 3, from this group of particular modelers. So they're going to suck carbon dioxide out of the atmosphere. Not they, of course, the next generation, rather, will suck carbon dioxide out of the atmosphere in the future to compensate for the fact that we aren't prepared to make the changes today. And it doesn't even finish at the end of the century. What they require, because we're not going to make these changes, is actually this goes on way into the next century. So we're locking the future into this because of our choice to fail today. And the negative, there's quite a lot of acronyms in climate change. I think it's to stop other people understanding it. So the negative emission technology that dominates the models, the only one in the models, is something called BECCS. Have you ever heard of this? So this is really fundamental to understand why it is the message from most scientists is so upbeat, or at least is not so downbeat, perhaps, on climate change. And in Sweden, Johan Rockström has a lot of this technology in his advice to governments in the papers that he's been involved with. So it's the most common one is biomass energy with carbon capture and storage, BECCS. And in this, what we're going to do is we're going to grow trees and plants around the world. And as they grow, they suck carbon dioxide out of the atmosphere through the normal processes of photosynthesis. We then capture these, we chop them down, we transport them all around the world in an infrastructure that is about as big as current world shipping. This isn't in the models. They've never put the detail in the models. So you have a new shipping industry that's as large as current world shipping that transports this biomass around the world. It is then burnt in power stations, and you capture the carbon dioxide, and then it goes up the chimney, the waste carbon. So the carbon dioxide is sucked out by the plant. You then capture it as it goes up the chimney. You liquefy it, and then you pump it through some pipes a few hundred kilometers, and you store it deep underground for a few thousand years. So this is what we're relying on in every single model advising governments. And a lot of the policymakers aren't aware, and certainly the journalists very often aren't. Let's also be clear, this has never worked at scale. We do not have an example of this working on any power station anywhere in the world. There are massive technical and economic unknowns. Burning coal and capturing the carbon is quite difficult. And we've only done that in one power station in Canada so far, and that was a very small power station, and it's proved really difficult. Here we're going to burn biomass and capture the carbon. That is even more challenging. So massive technical and economic unknowns, a huge efficiency penalty, so probably somewhere between 15 and 25% less efficient, because you have to do this process as well. And there's limited biomass availability. The aviation industry wants to run its planes on biomass. The shipping industry wants to run its ships on biomass. We already have about 5 to 7% of our car fuel running on biomass, and we want to feed 9 billion people. And perhaps it would be nice to have some parts of the planet that weren't there just for our immediate use, where you could actually have natural parks or forests and things that weren't there just to help us. So all of that. And this is, yeah.
Du måste använda mikrofonen, annars hörs det inte på...
Det här är så komplicerade termer så du får översätta.
Absolut.
Alltså jag undrar, är det verkligen, hur stor del är det BECCS man pratar om i de här IPCC-scenarierna. Är det inte först och främst nu CCS, och det är väl ändå en teknik som är mer nära till hands och som man skulle kunna koppla på egentligen vartenda kolkraftverk och stålkraftverk?
Yeah. So, how much is it just BECCS? How much is it also stuff like carbon capture and storage, which could be used at coal power plants now?
Yep. Well, this slide and the next slide, I hope will clarify this. So these are the scenarios going into the IPCC for a likely chance, so a reasonable chance of 2 degrees centigrade. So these are the scenarios here. And these are the ones that work out the amount of bioenergy, and most of this is BECCS across the century. So if you look here, by about 2050, 2060, this is the range we assume will be working. And notice there are virtually no models that don't assume this. Virtually every model has it in. Now, this may not mean much to you. It's about 200 to 300 exajoules after 2060. That's about half of current energy demand. So imagine all of the world's energy today, that half of that comes from burning plants. That's what we're planning for this century. So across the 21st century, a quarter to a half of future energy will come from burning plants and burying CO2. And that's in every model. You're going to be quite busy, I think, here.
Hi, I just have a technical question. If you liquefy the carbon dioxide and put it in storage, how do you keep it liquefied? And doesn't that require energy in itself?
No, because once it's down there, it'll be under a lot of pressure. So imagine one of the places they're talking about at the moment, I haven't gone into this in the slides, but one of the big concerns is, are there enough places where you can put the carbon dioxide? And it is fair to say that the geologists that work on this are not sure that there are. If you're somewhere like the UK or Norway, you can use old oil and gas reservoirs, and they're quite well understood geologically, and we think that the CO2 will be secure there. In other parts of the world, they're going to pump out what are called saline aquifers. So areas where there's a lot of sort of saline brine, salt water, and they're going to pump that out and pump liquefied CO2 in, and they're fairly confident it will remain there under high pressure, but it has to be a certain type of rock. It's got to have a cap on the rock that is impervious to carbon dioxide coming through. But at those pressures, it will remain roughly liquefied. It's on a sort of phase change state. It's not quite liquid, it's not quite a gas. So that's what they intend to do, but whether there's enough places that are suitable for doing that is a different issue. So, as an engineer, again, I just find this quite worrying that in the 21st century, the pinnacle of our ingenuity is going to be burning plants and burying CO2. I think we can come up with something slightly better in the 21st century. And the comment next about the CCS. Now, CCS is carbon capture and storage, and this can be used, in theory at least, it can be used for fossil fuel power stations to stop the carbon dioxide going into the atmosphere. You won't stop all of it, you'll probably only stop a reasonable proportion. Now, these again are the scenarios that feed in the IPCC. And this time, I'm looking at carbon capture and storage and fossil fuel use. The red ones here don't include carbon capture and storage. And as you notice, they have very little fossil fuel use. Because if you don't have carbon capture and storage, you can't use fossil fuels. Now, remember, we do not have any functioning carbon capture and storage power stations around the world, other than the one very small pilot scheme in Canada called the Boundary Dam, which is about 1/10 the size of a normal power station. It's a coal power station. So it's a very small one. And that has only captured 40% of the carbon dioxide they expected. So it's not proved successful. It's been technically really challenging. As an engineer, I think we will eventually solve these problems, but it will be at significant efficiency costs. And yet every single model assumes that you can have lots and lots of carbon capture and storage. And you can see why Statoil, BP, Shell, everyone else likes this. What it basically says is that we can carry on burning fossil fuels across the century. So we're having this technology which does not yet exist and will be very, very inefficient so that we can carry on burning fossil fuels. So both nets and carbon capture and storage, these technologies which don't really work, or either don't exist or don't really work at the moment, are used to maintain the status quo. So I would argue that Paris, some academics and policymakers, rather than focus on urgent and deep mitigation today, because this has massive challenging political and economic repercussions, they're going to rely on a non-existent technology at some point out in the future to remove huge quantities of carbon dioxide directly from the atmosphere, and that this will support an ongoing fossil fuel industry. In other words, nudge. a slight adjustment to where we are today, incremental change. And this is what really pretty much underpins all of the advice from Working Group 3 that feeds into government policies. And that's why the policies are so weak. Now, I just want to clarify here, I'm not opposed to negative emission technologies. I often get told that I'm too critical of them. So my position is this, is that I support us having a really well-funded research and development program on negative emission technologies and potential deployment if they meet sustainability criteria. But there's a problem with that as well. So you have to test, are they safe things to put in place? But we should mitigate emissions, reduce emissions, assuming they do not exist, at least for 95% of the scenarios we're developing. And if we did this, if we had real mitigation for 2 degrees centigrade, and the negative emissions that are in the models actually proved to be viable, we'd actually achieve them, then we have a theoretical chance of 1.5. And remember, we have signed up to that. Now, if we were not lying to the poorer parts of the world, then we should at least be trying to do that. And I would argue that theoretically it's just about viable to have 1.5 degrees centigrade of warming, which we've signed up to. But if we rely on negative emission technologies for 2 degrees centigrade, which we are already doing in Sweden, the UK, the European Union, and many parts of the world, and they prove not to be viable, and I only know of one modeler who thinks that they're viable, the people who produce the models. Most of the people do not think they're viable at the level in the models. Then what we'll have done is we'll have locked in 3 to 5 degrees C of warming. So we fundamentally fail by relying on negative emissions, and we are already doing that now. So what would a real 2 degrees C strategy? I've tried to sort of say this now, trying to paint out the picture as quick as I can. And I'm going to sort of lay out, well, what would you have to do? And I'm going to keep this really short. So there's no detail in this, but it's what I work on most of my time. Firstly, for the non-OECD countries, the challenge is huge, but not quite as severe as it is for us. They would need to reach a peak in their carbon dioxide emissions in the early 2020s. In Paris, they said probably the earliest would be about 2030 for China and 2040 for India. But I think this is still viable. China's emissions have until this year remained quite static, and I think China could come down quite quickly. But then they would need to increase their mitigation to about 10% per annum by the early 2040s and have no energy in their carbon system from the 2050s onwards. And if they did this, then the amount of budget that would left for the OECD would be about 10% per annum starting now, so starting in January. And remember, this is for the OECD, and the richer parts of the OECD, like Sweden, the UK, and some other countries in the EU, and the US, would have to be much faster, nearer 15 to 16% every single year, starting now. That's about a 60% reduction by 2025, or the work we've recently done for Sweden, for the Arfala region, where we looked at the Swedish budget, is about a 75% reduction by 2025, and fully decarbonised by about 2035 to 40. And what we're talking about there is our planes, our ships, our refrigerators, our industries, everything, no carbon in the energy system. Now that looks massively challenging, but I think that is much less difficult than trying to persuade our children that handing them 3 to 5 degrees centigrade of warming is viable. So it's our choice here. We are where we are because we have chosen to fail. And I think we have to start to recognize that and then be a bit more honest about what we need to do. So the 3 strategy points behind this. The first one is that I think we need deep changes in behavior and practices. I'm not going to go into the detail here. I'm just going to use some headline numbers that I regularly use. That the top 10% of emitters at a global level are responsible for 50% of global emissions. So some of these they're not all in Sweden or the UK, there are also some in China and some of them in India and other parts of the world. Now, if that 10%, so just that 10%, the other 90% do nothing, just that 10% reduce their emissions to the level of the average European, which isn't too onerous, that's what most average Europeans have to live on, then that's a 1/3 cut in global emissions. And bear in mind that our advice, the pledges made to Paris by every country of the world sees no reduction by 2030. And if we thought climate change and our children's future was actually that important, we could deliver this. It would be difficult, the policies would be challenging, but it's only 10%. The other part of the population would have to do something as well. But for this particular group, it would be massively challenging. And I would argue they can lead by example, that group. When I say they, professors will be in that group. I would guess that quite a lot of journalists are in the 10% group. We're probably quite a few of us in the 1% group. So we know who these people are, as I often say. We see them when we put our makeup on and when we shave. They're always facing back at us. The second part is that we need very stringent standards on energy efficiency appliances. I notice not many people have got laptops out, but quite a few of you got laptops and tables and so forth. My guess is there will be a difference in the efficiency of those of a factor of 2 or 3 between the different laptops. Why is that? If you buy refrigerators, why is there a difference of 4 or 5 in the efficiency of the different refrigerators that are the same size? Why is the average American car emits 212 grams of carbon dioxide per kilometre, yet the average British car being sold emits 118. There are lots of things that we can do with existing technology at no price premium to rapidly bring emissions down. So there are lots of technologies available. So we need to have very efficient, stringent policies on technology, tighten them every year, and this provides a long-term market signal. The company directors will all squeal, but the engineers will deliver, as long as you're in the basic laws of physics. And if you combine both the behavioral change and the technology change on the demand side, there's been quite a few people, including some of my colleagues and I in the Tyndall Centre, would say you can power down the energy demand in wealthy parts of the world by 40 to 70% in 10 to 15 years. So a dramatic reduction if we thought it was important. And that sounds almost impossible, but just think about it before when we're here. You know, we're in here on a day when there's it's not a sunny day, but there's daylight outside. We're in a not that older building. We've got the lights on, no windows, and then we have the air conditioning running, using energy, to take away the heat from the lights. You know, we have invented windows. They were a long time ago. We know what to do, and yet we talk about climate change with no windows, the lights on, and the air conditioning unit running, and then say, I don't think this will be a bit difficult. It would not be difficult. It's that we don't care enough to bring about these fundamental changes. But this won't be enough. On top of all this, we also need to dramatically change our energy supply. And the language I've used for this is a Marshall Plan, like the reconstruction of Europe after the Second World War. So it's that sort of scale of challenge. It's not a small adjustment. It is something that is much more fundamental and profound. And we have all the technologies, or we have most of the technologies. Energy storage is still a big issue, but I think it's one we can resolve through some other things, and maybe we can talk about that. But we have the supply technologies that are low carbon. But we also have to bear in mind that most of these are for electricity. And electricity at a global level is only 20% of the energy we consume. In Sweden, it's about 30%. So in other words, 70% of the energy the typical Swede consumes is not electricity. So we've got to find some way to make that low carbon. And the best thing to do there is we really need to electrify it. So whether that's our cars or our industries, because we can make low carbon electricity. It's very hard to know what else you would have. You can have some biofuels, maybe some hydrogen, but hydrogen normally comes by using electricity to separate water. So we need to have a much, much bigger electrification program than anyone is discussing at the moment. But from a political point of view, I think, coming from the UK, where we've got a lot of unemployment, or other parts of the world where there are unemployment, there is a massive sort of jobs agenda here. We've got 30 years, at least 30 years, of very high-level guaranteed employment if we are going to move to a low-carbon society. So maybe this won't play out particularly well for the economy. Maybe it will, I don't know. But from a jobs point of view, I think this is a real seller to politicians, I think. We need to think about that more. So in 2017, climate change is system change. It wasn't initially, it is now, because we chose to fail, we have made it system change. So the science logic of carbon budgets begs questions, fundamental questions of our norms and our paradigms, ones that we are not yet prepared to grapple with. We need a Marshall-style delivery of low-carbon supply technologies. We need to rapidly move to the most efficient technologies that are available. We need profound shifts in behaviors by the elite in our society who carry on just as if nothing was going on from a climate point of view. Our economic models simply are not up to the job. The current form of economic analysis from markets and neoclassical economics, it cannot deal with what we're addressing. There are other forms of economics that might help, ecological economics. But we mustn't use tools that are inappropriate for the job, and yet we still ask neoclassical market economists about what we should do. You wouldn't do that in any other science. We need to seriously think, do we really care about our children's futures? And I think that's a question we have to carefully think about, because I'm not certain we always do. And do we really care about people elsewhere? I'm fairly confident we don't seem to care about those very much. But we need to think about those things more carefully. And we also need to make sure that the poor parts of the world can leapfrog where we are and make a rapid shift to be low carbon. But that requires them having some money. And we've taken everything from them. I think it's about time we paid something back. So it's not aid, it's compensation, it's reparation. So we will help them make that transition financially. And they can help us as well to understand how to live low-carbon lifestyles. And as I said before, I think we should fund a negative emission research program, but not rely on it. This has to start now and be completed in about 3 decades if we want to hold to 2 degrees centigrade of warming, and much faster if you're going to stick to 1.5. So points to remember if you're going to question on mitigation, if you're talking to anyone in Sweden, it's carbon budgets that matter for temperature, not long-term targets. So ask the Swedish government, what are the carbon budgets it's using for its climate change law? I don't think it has any. The climate cares about CO2 molecules. It does not care about efficiency. So though efficiency is really important, and renewables are really important, they do not solve climate change. We've got a lot more renewables now, and yet the emissions have gone up, because we're using the renewables in addition to the fossil fuels. And that's no good. So it is absolute, not relative mitigation that matters. So when it comes to efficiency, what you need to ask people is, when they say, well, we're really improving our efficiency, do you mean what, per car or per plane, or do you mean the total? And they almost always are talking about just the per unit, and yet they're going to sell more of them, so the emissions will go up. And renewables have to substitute for fossil fuels. It's no good just adding more renewables to the system. We have to keep the oil and gas and coal in the ground. For 2 degrees centigrade, probably 70, 80%, probably 80%, I think, realistically, of fossil fuels need to be kept in the ground for something like 2 degrees centigrade, and much more for 1.5. And also remember that virtually all scenarios, sorry.
I just wonder, how do you look upon nuclear power? Is that the issue?
I'm not going to go into it now. All I was saying, nuclear, and in the slides, the pictures I put up just a few minutes ago, nuclear power was one of those. I used to live next door to one, and my dad worked in one. Nuclear is low carbon, even across the life cycle. It's about 5 to 15 grams of carbon dioxide per kilowatt hour, which is very similar to renewables. So from a carbon point of view, nuclear and renewables are very similar. There are a whole suite of implications of nuclear power, which I'm sure everyone here will have a different view on. And so from a carbon point of view, it's low carbon. Whether you think it's worth the other risks that come with it, about proliferation, what do we do with the waste, all of those other things that might be there, there are other sets of judgments we can make. I have my personal ones, and if you want to, we can come back to that in a minute. But then they're less informed by climate change. They're more informed by my other views about...
You didn't mention the economic side to it too.
Yeah,
I mean, it's very expensive at this. And we would need a lot of nuclear, wouldn't we? I mean, you are looking at BECCS and CCS, but talking about nuclear, it's also an issue.
Yep.
The scale we would have to use it on.
I mean, I can go through those numbers. Nuclear at the moment provides 2.5% of the world's energy and 11.5% of the world's electricity from 435 nuclear power stations. If we are serious about nuclear providing just, say, 1/4 of our energy, we would need probably between 1.5 and 3,000 nuclear power stations to be built and operating between now and 2040. So something like 100 new power stations every year at a global level. And we're currently building 75 at a global level. And they don't take 1 year. They take a decade or so. So they are expensive to build. They're actually quite cheap to run, as long as they work properly. So the economics is never... Economics is just I always say it's a post hoc justification for our view in the first place. We can make any... Economics is not a science. It's just... I mean, this has been a bit unfair, but it's almost just astrology. You change the discount rate, you change what the cost will be. So you can make things more or less expensive depending on what you want to justify. And economists have been doing this for years. I don't think it's very helpful to think about economics. A lot of NGOs have used economics to knock nuclear. But actually, to be honest, I'm less concerned about that. I think there are other problems with nuclear that make it more or less attractive. But the economics, it's expensive to build, certainly. And the other problem where you lock in an infrastructure, once you've gone down a nuclear route, it's quite hard to come back from it because it's so expensive from a capital point of view, and also you get a lot of contamination of equipment and so forth. So you sort of lock yourself in, and that's a risk. Lock-in is always a risk. The renewables are less susceptible to that. But maybe we can come back to that if you want to ask about nuclear. Virtually all high-level scenarios assume negative emission technologies. And virtually every scenario has a focus on supply. Demand issues have always been the Cinderella issue in climate change and in energy. People always ignore the demand side, and yet it has a real chance to offer some hope here. So if you're sat interviewing some climate scientist, ask them the questions I was thinking what you might need to ask. Do they take account of equity between poorer and richer nations? And don't just say yes or no. Get them to explain what they've done to take account of equity. What chance of 2 degrees C or 1.5 underpins their analysis? Often what they'll do is say, oh, this is our 2 degrees C scenario. Then you look at it, and it's actually a low chance of 2 degrees centigrade. So if you got on a plane, would you accept a 30% of it crashing, chance of it crashing? You probably wouldn't. Would you even accept a 60% chance of it only landing, so only a 40% chance of it crashing? No one would get on the plane. Yet when it comes to climate, we call a 60% chance of staying below 2 degrees centigrade, which is significantly dangerous. We call that a reasonable probability. So ask them about what chance they're assuming, because a lot of the time they will be using a low chance of 2 degrees. Do their conclusions rely on negative emission technologies? And almost that, certainly the answer will be yes. Then you can ask them how much. So you can start to probe them quite quickly. How much does energy demand? What's the role for that in their findings? And they'll sort of fluff about that a little bit, but actually there'll be very little energy demand in there. So there are some, the new Statoil scenarios are quite interesting. They've got some demand side in there. What assumptions have they made about aviation and shipping? Virtually every set of scenarios ignores them, including the new Swedish climate change law. Aviation and shipping is probably somewhere about towards 15% of Swedish emissions, completely ignored, like every other country. And do you take account of imports and exports? That's often ignored as well. And most wealthy countries of the world have offshored their manufacturing to poorer parts of the world and then blame them for the emissions. So you repeatedly hear that about China. China's emissions are about the same as the average European. That's because they're making my laptop and my clothes and probably the covering of these tables. And
I just, this thing about poorer countries, because I used to live in India,
Yep.
and I was always a bit confused by the Indian government's attitude, because I thought this could be a vanity project for them. They could lead the way with renewables, and they just don't care. But was there any way to talk to, and the thing is, I miss New Delhi all the time. I would love to move back, but I can't because the pollution is disgusting. So, and it was pretty clean when I lived there. So how can you talk to developing nations about making it a vanity project, about leading the way?
I mean, there's been a lot of people from the West, the colonial West, trying to talk to these other parts of the world about what they could try and do. A lot of the time it's resources, which is less of an issue in India, but certainly quite a lot of the African countries. And that's why I think we need to be thinking about using our considerable resources in the Northern Hemisphere to help some of the poorer parts of the world. That would be helpful. It's interesting in India at the moment, India had until about 6 months ago a real major program for building lots more coal-fired power stations. And actually, the economics there has proved important because the capital cost of the solar is so much cheaper now. So they've pulled back almost all of that now, and they're looking at whether they can use solar instead. So there are changes occurring in other parts of the world. And I would also say it'd be nice to go back to some of these parts in India, but of course, by getting there, we add to the problem as we get on a plane, just because no one counts the emissions. Yeah, the climate does. Well, a friend of mine has just cycled there, actually. It takes quite a long time. I can give you his route if you want. But yeah, so I think we have to be quite careful. I'm not saying you're suggesting this. We have to be quite careful, I think, again, about sort of rich white colonials meandering into other parts of the world and saying, we've got a plan for how you can become low carbon. They're already low carbon. We're the high carbon ones. We should perhaps be inviting them over here to tell us, how do you live a prosperous low carbon lifestyle? Because a lot of these people in poor parts of the world do live good quality lifestyles. They're not all just like our television programs tell us about people in poverty and struggling. There are people living good lives as well. So we must take account of imports and exports, and not just blame poorer parts of the world. So there are lessons to learn, I think, right around the globe. We need to be much more open to learning from each other. So I think on that, that should say that in Swedish. That's an old English slide. I'm sorry, I apologize. That's one bit of Swedish I normally say, thank you for listening. All right.